ECO, Natural Technology. Business Model. We are launching a new robot line aimed at cleaning up the oceans. This will be funded by donations and 30% of sales on all of our other products. These will not be on sale and will only be used to clean up the oceans. Concept. We aim to have an effective and safe way to clean up debris in the ocean, the first of which will be an autonomous robot shark mainly focusing on the 5 garbage patch zones starting with the North Atlantic zone. Design. Fuel. Pure oxygen fuel cells use pure oxygen as the air for the fuel to combust. This is highly efficient, but the technology is very new. Nuclear. Great option, but obviously bad for the environment and hard to control. Hybrid. The electric works, but gasoline is more explosive than diesel and causes spontaneous combustion. Diesel electric. A diesel engine is powered when the snorkel is above the water because internal combustion engines need air to run, then uses an electric motor underwater. Fuel/propulsion. We chose full electric, allowing for a completely clean way to provide power while also allowing us to run underwater in an effective manner. This powers 2 internal propellers in a separate standby chamber. It floats by using ballast tanks like submarines, using compressed air to rise and adding seawater to sink. Sensors. There is a camera for manual observation and a sonar along with other underwater monitoring devices to test the extent of the pollution this trash has created. Dissolved oxygen. Test how much oxygen is in the water. Turbidity, cloudiness of the water. pH. The ocean is slightly basic, but after the ocean has absorbed CO2, it becomes more acidic, harming the animals around it. Conductivity. It comes from dissolved ions in the water or tests of how many invisible ions are in the water. Salinity. This is important because depending on the fish, it can survive in salt, non, or both. Materials. Carbon fiber has the best strength-to-weight ratio, but is extremely expensive. Titanium also has a great strength-to-weight ratio and is about half the price of carbon fiber currently. Aluminum is cheaper than all, but its weight-to-strength ratio is lower than titanium. After testing, we went with titanium for the final prototypes because of its strength and price. Failsafes. Look, a shark is usually an apex predator, causing most other animals to hide and allow access to more locations. Limp mode. If attacked and unable to escape, it will cut power and await pickup. Escape. If it is being chased, it will return to the nearest pickup location. If it is low on battery, it also returns to the nearest location. And if it runs out of battery, it floats onto the surface and sends an alert to be picked up. Protection in lawless waters. NATO has approved the use and offered protection if needed. It is an alliance consisting of 29 countries that was originally created for security against the Soviet Union. It now helps in time of war and security needs. Facilities. Drop-off locations. Pick up in boats or if close enough to the facility, returns there. Emergency locations are small plexiglass pods located near beaches. A circle metal piece slides open to allow entry to pods. If anything foreign is in the water, it opens and pushes water into the pod. Manufacturing. Made in the U.S. Everything is assembled by hand and tested in an indoor environment. All salvageable waste is melted down and used for other parts. The toxic materials like lithium are used to create batteries, and some are burned or converted to recharge the batteries. Repair facilities. Currently we are making mobile repair boats, but for now all we can do is retrieve the robots and take them back to the main manufacturing building with a repair lab there. Projections. Cost/launch date. It will cost us about another $250 million to develop and will take us another year to complete if we do not receive the funds. The first robot could launch as soon as May 2022 after the final prototype is made. Reflection. What worked? I wanted to incorporate a way to present without having to stand in front of the class. I overcame this by doing as you see here. I also wanted to explain as much as I could about the considerations, so instead of stating every single detail, I summarized what was important about each one. What didn't. Originally I planned to make a working model, but after consideration, a model of this scale would have taken months to develop. This is not because of the size, but its complexity. It is difficult to recreate things such as ballast tanks and working propellers while making everything waterproof and wireless. I learned a great deal about things like fuel, engines used, metals, and things businesses have to consider when making a product, as well as how much effort it takes to go over every aspect and clearly define or accomplish it when making something.